Question number 3 is going to have more practice with inverses. So you may find that with a little bit more practice, you'll actually feel more confident with these. And you may find that it's just above your head. So be honest with yourself and do as much as you feel comfortable with. In question number 3, letter A, we're going to stick with the same process that worked in numbers 1 and 2, which is the two-step process. First, switch x and y, and then get y by itself, using opposites as our guide. I'll also make a little note to ourselves here that usually when we get y by itself, that reverse order of operations, or SADMEP, can be a very helpful guide. So I'm going to write that there just as a reminder that if you need to, these are the steps to follow, kind of like a blueprint, if you will. Let's start with letter A, and let's see if we can follow these steps. First step, switch x and y. So instead of y equals, I'll have x equals log base 9 of, instead of x, y. So notice I don't change anything about the problem. I just changed the x to a y and the y to an x. That's it. Second step, get y by itself. Now, I'm looking at the letter y, and the only thing on its side of the equation is a log. And this is where I go back to understanding opposites. If the only thing I have to get rid of is a log, I just have to ask myself, well, what's the opposite of a log? The opposite of a log is an exponential. That's how I'll get rid of it. I need to write this in exponential form to get rid of the log. Remember, subtracting cancels adding. Dividing cancels multiplying. Square rooting cancels squares. Logs cancel exponentials. And it all works vice versa. Exponentials cancel logs. So I'm going to write this in exponential form. If you're confused in this way because you're like, wait, that's not where log usually is when I do it exponential, then you can reverse the problem a little bit and put log base 9 of y on the left and x on the right. It doesn't do anything. You didn't actually do anything to accomplish anything, but it does make it visually a little more familiar for those of us who need it. If you prefer writing in exponential form, now hopefully that little loopy arrow will make sense. We have 9 to the power of x equals y. Now it's in exponential form, and notice what happened. Y is by itself. That's what we wanted. So y equals 9 to the power of x must be our inverse, because as soon as y is by itself, we're done. We're good to go. As long as you kind of understand that, this might be a good time to try other examples that also have a log. So as I look at other examples on this page, I can see that the other ones that involve a log, which I'll kind of color code so that way we're thinking of them together, are as follows. Besides letter A, which has a log in the original problem, letter C has a log in the original problem, letter E has a log in the original problem, letter G has a log in the original problem, and so does letter I. Now, to be fair, G and I are tougher examples. Those are examples where I would say if you can do them, that's great. And if you can't, don't worry too much. Those are slightly more complicated examples. So I'm going to leave those as a challenge, but not mandatory. Let's focus on C and E and see if we can get those done, since they seem to be kind of related. Let's jump to letter C. And let's again keep our steps in mind. We're going to switch x and y, and then get y by itself. So first step, switch x and y. Instead of y equals, x equals log base 6 of, instead of x plus 1, parentheses, y plus 1. Okay, now we need to get that y by itself. Now, in terms of order, I can't subtract the 1 first. It looks tempting, but I have to remember the plus 1 is actually in parentheses, and parentheses are the last step in our SADMEP algorithm. So I need to backtrack. I can't subtract, can't add, can't divide, can't multiply. The only thing I can actually do is exponentiate this. And the only reason I can exponentiate is the log is the only thing outside the parentheses. And the log has to be gotten rid of by exponentiating. Again, I'll reverse the order of this question just so that way the order isn't messing me up, because I want it to look familiar all the time. Now I'll exponentiate, same way I always do. Base of 6 to the power of x equals the thing in the middle, y plus 1. This is looking pretty good. Y is almost by itself. And it looks like it's actually kind of easy now to get y by itself. The only thing I have left is this plus 1, and I can get rid of plus 1 by subtracting 1. Unfortunately, minus 1 isn't a like term with the 6, because 6 is to the power of x, but 1 isn't. So I'm just going to write this as y equals 6 to the power of x minus 1. I can't really subtract them, so I'll just leave them separate. Looks pretty good. Let's try the last log example just to make sure that we have something to work with. Let's try letter E. And again, let's stick with our steps. Same idea as before. First step, switch x and y. So instead of y equals, x equals 4 plus log base 5 of, instead of x, y. Now let's get y by itself. I need to get rid of the 4 and I need to get rid of the log. So let's ask ourselves, which thing should I deal with first? Looking at my options, s, can I subtract? Ooh, I can. I'll subtract the 4 first. Now I can't really subtract on the left-hand side, so I'll just write this as x minus 4 equals log base 5 of y. Now to get y by itself, what's the only thing I have left to get rid of? Oh, I have to get rid of that log, which I know involves exponential. To get rid of a log, we use an exponential. If it's confusing for you to see it this way, switch the problem so it says log base 5 of y on the left and x minus 4 on the right. Sometimes that helps. Now let's go exponential. I'll use my little loopy arrow to help. 5 to the power of x minus 4 equals the thing in the middle, y. And sure enough, y is by itself, so it looks like I found the right inverse. It looks like I found the right thing. Y equals 5 to the power of x minus 4. Hopefully you saw enough repetition there that you're like, oh, same thing every time. And it kind of is. That's sort of the point. So, now that you've seen some log examples, in the last video we'll talk about some exponential examples. If you really want to challenge yourself between now and the next video, you can try letters G and I, but remember those aren't essential questions. Those are actually a lot harder. So do so at your own risk, but don't feel obligated.